Hello everyone. So in this video we will discuss that how we can remove a loop from a singly linked list. So friends, in our previous videos we saw that how we can detect a loop in a singly linked list, and after detecting the loop we also saw that how we can find the starting node of the loop, and we demonstrated both the algorithms using Floyd cycle detection algorithm, and we also saw the proof of Floyd cycle detection algorithm, that why it works. So based on similar concept, we will see that how we can remove the loop from the singly linked list. So before we start, in case if you are new to my channel, then please subscribe to my channel so that you never miss any update. So friends, here you can see, let's suppose we are given with this singly linked list which is having a loop starting from node 3. So here 3 is pointing to 4, 4 is pointing to node 5, and 5 is pointing to node 6, and node 6 is again pointing to node 3. So here you can see that there is a loop, and our task is to remove this loop. So the only way in which we can remove this loop is if somehow we reach to this node and we break this link. And once we break this link and if we assign it to null, then it will become a singly linked list which will not have any loop. So friends, the idea behind this algorithm is, it's very much similar to what we discussed in our previous videos, that we create two pointers. We name them fast pointer and slow pointer, both starting from the head, from here, and then we provide a while loop. So inside this while loop, what we do is, we move fast pointer by 2 steps. So here you can see we are assigning fast pointer next. So for example, if suppose fast pointer is here, its next is this node and its next is this node. So we are moving fast pointer by 2 steps and we are moving slow pointer by 1 step. So once they will reach inside this cycle, and if the singly linked list contains a cycle, there will be a situation when slow pointer and fast pointer will point to the same node, which will prove that there is a loop in the singly linked list. So this idea we have already discussed in 2 of our videos. So the first part is to find that meeting point of slow pointer and fast pointer. So we'll quickly go over the algorithm to find the meeting point of slow pointer and fast pointer. So here we are starting both fast pointer and slow pointer from head, and we are providing a condition in while loop as fast pointer should not be equal to null and fast pointer next should not be equal to null. Because here we are traversing fast pointer by 2 steps, we have to provide this check, because if fast pointer next comes out to be null, then here we will get a null pointer exception. So we are providing this safe check here. So currently fast pointer is not equal to null and next is also not equal to null. So we'll quickly go over this demonstration because we have already seen it in our previous videos. We have moved fast pointer by 2 steps and we will move slow pointer by 1 step, and after we perform one iteration, we simply check that whether they are pointing to the same node or not. So currently they are not. So after second iteration, this is the situation, and still they are not pointing to the same node. Still slow pointer and fast pointer are pointing to different nodes. So friends, now here you can see that both slow pointer and fast pointer are pointing to node 5. It means that there is a loop, and our if condition slow pointers equals fast pointer comes out to be true. Now which will signify that there is a loop. So in the second part of the algorithm, which is what we want to remove the loop. So here, now we will call remove loop method and will pass in the slow pointer. and once this method will end, this loop will be removed and we will simply return from this method. So here, as we have passed slow pointer, so it will still point to node 5 because this is the meeting point of the fast pointer and slow pointer. So friends, in one of our previous video, we discussed that how we can find the starting node of this loop, where what we did was, we created a temporary variable, we started it from head, and then we had moved temp by one step, slow pointer by one step, and where they would have met, that was our starting point of the loop. And we also proved the algorithm mathematically that why moving temp by one step and slow pointer by one step in a while loop will make them meet at the starting point of the node. So this algorithm we proved in our previous videos, so you can watch those videos. So here we'll apply the same analogy. We start from the head, which would be our temporary variable, and slow pointer from the meeting point of slow pointer and fast pointer. Now here we are providing a while loop. So when we were actually finding the starting node of the loop, our while loop condition was that perform the iteration till slow pointer meets the temporary node, and inside this while loop we were moving both the pointers one step. But now here you can see that as singly linked list contains a loop and we want to break this link, so we don't have to go till the starting point, we have to go a node before that and we have to remove this link. So the only way to reach node 6 is, instead of comparing slow pointer with temp here, we are simply comparing slow pointers next to temp next, because we know that when slow pointer will reach at node 6, temp will reach at node 2, and the both pointers next will point to the starting node of the loop. So therefore we have to break this while loop at that point, because we have reached slow pointer to a node which is just before the starting point of the loop. So let's see how. So currently slow pointers next is not equal to temp next, because temp next is pointing to node 2 and slow pointer next is pointing to node 6. So the condition in while block comes out to be true. We move temp by one step. So temp goes to its next node, where we assign temp dot next value to temp. And similarly, we will move slow pointer by one step by assigning slow pointer next to slow pointer. So slow pointer next is node 6. So now slow pointer will point to node 6. Now friends, here we again check whether slow pointer next is equal to temp next or not. So slow pointer next is node 3 and temp next is also node 3. So therefore this condition comes out to be false, because slow pointer next is equal to temp next. So this is the only minor difference between finding the starting point of the loop and finding a node before the starting point of the loop. And why we need a node before the starting point of the loop? Because we need to break this link, and the only way to break this link is if we have reference to this node. So therefore here the only difference between the two algorithms is this condition. If you want to find the starting point of the loop, then this while loop condition becomes slow pointer not equal to temp, and if you want to find a node before that, then you have to provide this condition that slow pointer next is not equal to temp dot next. So here this condition comes out to be false and while loop will terminate. So at the end, in order to break this link, what we'll do is we simply assign null value to slow pointers next. So it would look something like this, that slow pointer next is pointing to node 3. So this link will go away and now it will point to null. So friend, after this assignment you can see that our singly linked list, which had a loop in between, now it will end with a null value. So friend, this was the demonstration of the algorithm step by step. I hope you have found this information useful. And in case you have found this information useful, then please like this video. And if you are new to my channel, then please subscribe to my channel so that you never miss any update. Thanks. Have a nice day.